Hi, I'm Kevin Keller, the pragmatic statistician. In this episode of Street Stats, we're going to cover some subtleties associated with Pareto charts. Now, when you learned about Pareto charts, your instructor likely told you the story of Vilfredo Pareto, who was an Italian economist in the 1800s who hypothesized that 80% of the wealth was owned by 20% of the people. Joseph Duran, a quality icon who no longer gets his due as a quality pioneer, took that concept and related it to quality. 80% of the defects were created by 20% of the potential causes. Cool. But what you took away from that class is that it always works. That is not the case. What you must look for when you do a Pareto analysis is when you do not have something and it happens more than you think. So let's look at a Pareto chart. So we can see that machine B is by far our largest, followed by H, G, E, and so on. Universally, people are inherently trusting these numbers as absolute. Those are the facts. That's what happened in this time frame. So if we fix B, then we fix H, then we fix G, then E, and so on, we're going to fix our problem. But we've forgotten about the 80-20 rule, and we forgot about variability in our data, and we forgot about predictability. B only accounts for 25%, and B and H together only account for 40%. But you say, so what, Kevin? B is the largest category. Those are the facts. Okay, maybe. But now what you believe is that period after period, we're going to see that same performance repeated over and over again. So now we're going to fix machine B. Will that really fix anything? And I would suggest no. You haven't identified the true root cause, and now you're spending your valuable resources working on something that isn't the root cause. Now, in this particular example, we have 8 categories, 8 machines. So let's imagine that we have an 8-sided die, whatever that might look like, versus a 6-sided die, where every side of the die has an equal chance of being selected. Now, in this case, since we had 185 observations, we're going to toss this 8-sided die 185 times and record the frequencies. Now, I did this in Excel and I copied it over to Engine Room. I'll show you that in a second. You can do the same exercise if you wish. If you don't know how to generate these numbers in Excel, just ask ChatGPT. Create a discrete uniform distribution of integers between 1 to 8, and that'll work. So let's look at this data set. So I did this a total of 4 times just so you could see what could happen purely at random. I counted up how many occurrences occurred of each of them, and I created 4 Pareto charts. Here's the first one. So we can see that side 4 and side 7 was 28, 27, 25, and so on. This occurred purely at random. So what you need to look for is, does it gradually taper off? If it gradually tapers off, that tells you you have randomness in your data. This variable has nothing to do with it. In this case, side number 8 was by far the lowest. And then let's see what happens when we do it a second time. All of a sudden, side 3 pops up and it's got a higher bar than the rest of them. Therefore, side 3 must be special. And we know if it's uniform and it just occurs at random, we could see this. And these numbers, these cumulative percentages, slightly lower than what we saw in that machine example not too long ago. And then I did it again, And here you can see a gradual tapering, but this number 7 side, boy, that must have nothing to do with it. It must not be important. It can occur at chance and chance alone. Again, we're looking for, does my data taper off over time? And then I did it a final time, and lo and behold, side number 3 popped up for a second time. So side 3 must be important. Again, you're looking at this gradual tapering, and that is giving you the answer. So, whether it's machines, shifts, offices, countries, whatever it is, that has nothing to do with it. Now, another way to think about this problem is, if I did nothing, will I see that same pattern repeat over and over and over again? Now, if it does look the same period after period after period, then there might be some relationship there, if there's no intervention, of course. If they exchange places without intervention, then it's random. Now, are you going to get exactly an 80-20 rule when something is real? No, of course not. But if you see a gradual decline, there's nothing here. Now, some people are very disappointed by this. I always advocate eliminating a variable is valuable information. We know that variable is not involved, and it saves time from team members and senior management going, well, we need to go investigate that. Now you're down a rabbit hole that sucks all of your resources, and you're losing time solving your problem. So be careful out there. The streets are messy, and so is data. But remember, there's always a way.